polymers. Condensation polymerization involves two different types of monomers, each with at least two functional groups, and each functional group reacts with a group on another monomer to form links, creating polymer chains. Through examples of condensation polymers: polyamides, polyesters, polypeptides, proteins. Polyamides, polyesters, polypeptides, proteins. State what reaction produces polyamides. It's the reaction between carboxylic acid and diamines. Carboxyl groups of dicarboxylic acid reacting with amino groups of diamines to form polyamides, forming amide links, okay, producing polyamides. So you got your dicarboxylic acid, HOC double bond O or C double bond O or H, plus your diamine, NH2 R dash NH2. And what happens is, so you can see here, this OH and this hydrogen leaves as water, and then you're left with everything else. So HOC double bond O or C double bond O, and then this is gone, so then you've got your NH there. Then you carry on with that, and that's your amide link, C double bond O and H plus H2O. Nylon 6,6, a polyamide made from 1,6-diaminohexane and benzene dioic acid, hexane dioic acid. Nylon 6,6, a polyamide made from 1,6-diaminohexane and hexane dioic acid used to make clothing, carpet, and rope. So in here you got 1,6-diaminohexane, two NH2 groups, hexane. It's got to be CH2, 6 in the middle. And then you've got N here, plus your hexane dioic acid. So you've got two C double bond O OH, C double bond OH, and the middle, because it's going to be hexane, one carbon, CH2, 4. And then what you form is basically what happens in this case then, that H and that OH, well, that's going to leave as water. But also this H and this OH leaves as water. So then you've got this NH, CH2, 6, and then you've got NH, and then you've got bonded to C double bond O, CH2, 4, C double bond O, N. And that's nylon 6,6 plus 2NH12. Kevlar, polyamide made from 1,4-diaminobenzene and benzene 1,4-dicarboxylic acid, using bulletproof vests, bolt construction, and car tires. So 1,4-diaminobenzene, benzene ring, amino group here, that's fine. And plus your benzene 1,4-dicarboxylic acid, benzene ring, carboxylic, C double bond OH here, C double bond OH here. Then what happens is this hydrogen and this OH, well, that's going to leave as a water molecule. But again, this hydrogen and this OH is going to leave as a water molecule as well. So then you're going to get NH, your benzene ring, NH, and then your C double bond O, then your benzene ring, and then your C double bond O. Bracket, that's an N plus 2NH2O. You lost two water molecules there. Reaction between carboxyl groups of dicarboxylic acids can react with the hydroxyl groups of diols to forming ester links. So your dicarboxylic acid HOC double bond OR, C double bond OH, plus your diol HOR-OH, HOR-OH, diol to form your ester link. And polyesters are polymers joined by ester links. Polyesters, polymers joined by ester links. So what happens? This OH, this hydrogen, that's going to go. But in this case, that's obviously this part is going to stay the same. So that leaves you form your ester link, C double bond O, O R-OH. This part, ester link, C double bond O. Terylene PET formed from benzene 1-1,4-dicarboxylic acid and ethane-1,2-diol using plastic bottles, clothing, sheets, and sails. So you got benzene 1,4-dicarboxylic acid. There you go. Carboxylic acid group here, carboxylic acid. C double bond OH here, C double bond OH here. Ethane 1,2-diol, methane, ethane. OH group here, HO group there. That's N. Then what happens? That's this OH and one of these hydrogens is going to leave to form water. Again here, that's going to leave to form water. So you're going to be left with C double bond O, benzene ring, C double bond O, and then you've got your O, C, yeah, and then you carry on with that. Because remember, that's your ester link. Reaction between carboxyl groups of dicarboxylic acids reacting with hydroxyl groups of diols forming ester links. Reaction between carboxyl groups of dicarboxylic acids can react with hydroxyl groups of diols forming ester links. And they form terylene PET plus 2NH2O. Condensation polymerization can be reversed by hydrolysis. This is when H4 molecules are added back in and the links have been broken. So here you got your amide link. So I can see it's an amide link, it's not an ester link. So if it's an amide link, I'm thinking, okay, so what reaction produced polyamides? Well, the reaction between carboxyl groups on dicarboxylic acid reacting with amino groups on diamine. So I'm going to form a carboxylic acid. I'm going to form a diamine. Dicarboxylic acid, diamine. So now I've seen that, and now I know what to do. Plus 2 NH2O to form. Well, I'm going to form dicarboxylic acid. So C double bond OH here, or C double bond OH. There you go, dicarboxylic acid. And then this amine link, NH2 R dash NH2. Perfect. And remember to put those ends there. That's your amide link, dicarboxylic acid plus your diamine. Now, if it was an ester link, C double bond O, then I'd be like, okay, what reaction produces ester links? Or polyesters, which polymers joined by ester links. Well, it's a reaction between carboxyl groups of dicarboxylic acids and hydroxyl groups of diols forming ester links. So then I'll be like, okay, I'm going to form a dicarboxylic acid, I'm going to form a diol. And then the same thing there. Polyamide made from reaction of carboxyl groups and dicarboxylic acid reaction with amino groups and diamines, yes. Why are condensation polymers stronger than addition polymers / more rigid as well? Well, condensation polymers made up of chains containing polar bonds. Plus, as well as van der Waals forces, got permanent dipole-dipole forces and hydrogen bonds between the polymer chains. So why are condensation polymers stronger than addition polymers? So condensation polymers made up of chains containing polar bonds, as well as van der Waals forces containing permanent dipole-dipole forces and hydrogen bonds between the polymer chains.